Hi, everyone. Thanks for joining. My name is Dustin Spinhern. I'm one of the architects with the customer success team at VMware. So the purpose of today's call is to do a pre-onboarding review of the VMware Cloud on AWS service. So I'll touch a bit on my team and what our role is in the process, go over some important concepts of the service, touch on storage and networking of an SDDC, and then do a quick review of the workload onboarding process. We'll also finish up the BMC console tour. So the customer success team, that's my team at VMware. So what we are meant to act as a permanent resource for all customers of VMware Cloud on AWS. And so some of the things that we provide are pre-onboard education, like we're doing now. We do initial use case reviews and consulting. We provide assistance with account activation, SDDC creation, and we provide guidance and consulting on the subject of workload migrations and onboarding. So as part of that, when we get into specific tools like HCX, which are used for that, for those activities, we provide consulting, installation guidance, services like that. Now, finally, we are also acting as an ongoing technical and account management resource for customers. So let's get into some important concepts. So the first thing we'll talk about is the org, or the cloud services organization. So the org is a top-level construct. Within the context of this conversation, an org can be thought of the thing that owns multiple SDDCs. So an org will have one or more SDDCs associated with it. Orgs also have users. Now, currently there are two types of users. So we've got the org owners and the org users. So the org owner is someone that has the ability to manage SDDCs, so they can create, delete SDDCs, add hosts, etc. Org users can do all of those same things as well. Now, the org owner has one additional capability, which is to add org users. And so that's really the only difference between the two roles. Now, as far as activation is concerned, during the activation process, there's a special org owner called a fund owner. And the fund owner is going to be the person that has a My VMware profile, has all the required fields filled out in that profile, and has funds associated with that profile. And so it's the fund owner that's actually going to be completing the account activation. Now, one of the things that we like to point out is, number one, required fields in the My VMware profile. You have to have all those filled out, and if not, then the activation tends to fail. The other thing that we want to have is the email address. It's important to have an email address that actually goes somewhere, that's going to be checked. And the reason for that is, we actually send an activation email, which has a link, which is required to actually activate the service. And so if that email goes to an alias or to somebody in the accounting department that doesn't know what to do with it, and it might get lost, and you won't be able to activate the account. So it's important to have an email address that actually goes to an address that is checked by someone. So the other aspect to talk about is the customer AWS account. So one of the value props of the service itself is the fact that we are resident directly within Amazon data centers. And so we have, as part of that, the ability to provide access to Amazon services directly to the SDDCs. So in order to do that, we have to do account linking. And so what that means is all customers will have their own AWS account that is dedicated to them. And then as part of the org activation process, what we'll do, we'll hit a step where we ask for the Amazon account information. And so once you provide that, we're actually going to run a cloud formation template within that account that is going to create some additional roles. And these roles are in place to allow us to link SDDCs to resources within that account. And I'll get into what that means next. But the important takeaway here is that the cloud formation template itself, needs to be run by somebody, number one, that has a user account in that Amazon account and also has the correct permissions. We tend to say admin permissions. I think it's actually doesn't quite require admin, but just to be on the safe side, somebody with admin privileges is probably the right level of access we're looking for. And so what we end up running into sometimes is that the fund owner that's actually going through the activation process turns out that they're, they may actually be from accounting or somebody that's not a cloud admin. And so they end up, we hit the situation where they don't have the permissions, within Amazon, or they don't even have an account. And so, they'll either have to go away and, get that taken care of, or they can just have somebody from the cloud team there, as part of the activation process. So whenever they hit this step, that person can log into Amazon and run the cloud formation template on their behalf. And so that's kind of the ways of handling those, the permission situation. So the last thing we'll talk about here is the SDDC itself. So the SDDC, just to rehash, SDDC is bare metal host dedicated to that SDDC. So every time you spin up an SDDC, you get dedicated hardware hosts. On top of that, we install ESX, vCenter, NSX, vSAN. So that forms the basis of an SDDC. Now, I mentioned the linking process. So what we want to be able to do is provide the SDDCs with direct access to Amazon services. And so how we accomplish that is by creating a link into a subnet within one of the VPCs of the customer account. And so what we end up doing on the back end is we actually create ENIs for every ESX host that we have. We create an ENI within this subnet, and that gives us a direct link into that subnet. Now, the key consideration here you want to keep in mind is that subnets are associated with availability zones, right? And traffic within an availability zone, as between subnet 1 and 2, there is no charge for that traffic. Now, as soon as you cross an availability zone, so subnet 3 in the example here is in a different AZ, as soon as you cross that, you incur a cross AZ bandwidth charge, right? And so it's a small charge, but it may not be completely insignificant. So it's something to be aware of. Now, because we want to be able to provide SDDCs, zero charge bandwidth, what we do is the subnet that you choose for this linking, we look at the AZ of that subnet, and then we actually deploy the SDDC within that same AZ. So that sort of ensures that the traffic from this, between the SDDC and the subnet, is not incurring any sort of charges. Now, the consideration you want to keep in mind here is that if for example, you have a bunch of EC2 resources in subnet 2 and subnet 3, but that the SDDC really mostly needs to talk to stuff within subnet 2, you want to make sure that subnet 1 is set up to be in that same AZ so that you don't incur the bandwidth charges. Now, the final thing I want to touch on and just mention briefly is the permissions model of the SDDC. So SDDCs, because this is a managed service, we don't provide full admin access to the SDDC because we have certain infrastructure, vCenter, NSX, that's all pre-configured as part of this, and customers aren't allowed to access that stuff. And so we don't provide admin rights to vCenter, but what we do provide is a non-admin role that has the rights to create workloads within the SDDC, and we also provide the ability to manage the networking, et cetera, through the console. So you have basically the full ability to manage workloads, but not full rights, not full admin rights. And so the thing to keep in mind there is, typically that doesn't impact workloads, your ability to spin up and tear down workloads, manage workloads. But what it can impact is potentially your ability to integrate tools. And so with vCenter. And so if you have tools that require admin access to vCenter, that's not going to work. And so you want to make sure that whatever tools you're planning to integrate within the SDDC, that you review the permissions requirements required for those tools. So now let's get into a bit on the architecture of an SDDC. So this diagram here, what we're seeing is the storage model of an individual host with the current hardware profile that we have today. And so each host, number one, I mentioned that vSAN is set up on the SDDC, but each host within the SDDC is set up with a group of 8 disks, right? NVMe flash devices. Now these disks internally are carved up into 2 vSAN disk groups. And the first disk of that disk group is the cache disk. The remaining are used for storage. And so what you end up with is about 10 terabytes of storage per host on the SDDC. And so if you have 4 or 5, 6 hosts, whatever you have, your storage goes up by that amount. Now, because we are using vSAN, the actual usable storage is a different story, and we'll get into that here in a second. Now, vSAN operates on the notion of storage profiles or storage policies. So policies that you use will impact the usable storage. And so we'll take this first one as an example. So let's say that you're using RAID 1 FTP1. Well, number one, that's happens to be the default policy that we're actually using within the SDDC. But number two, you have to keep in mind that there's a certain overhead to that. Since it's RAID 1 mirroring, basically what this means is that for every 100 gigs of data that you actually want to store, we actually require 200 gigs to actually make that happen because we're mirroring it. Now, when you start getting into RAID 5, the overhead numbers start going down a bit. Now, there's also this host requirement over here. So some of these configurations require additional hosts. And so that's the purpose of this table, is to highlight that as something to keep in mind when you're deploying the SDDC. Now, the other aspect to consider is that we have dedupe and compression enabled within the SDDC. And so the type of data that you're storing actually will also impact the amount of available storage. So if your data is highly compressible and it's maybe a bunch of Windows images that can be deduped pretty easily, then your storage capacity is going to be higher. So that's another consideration to keep in mind. Now, this tool here, this is a tool that we've put out there in order to help size the environment. So if you know what workloads you want to move over, you can use this tool to help determine how many hosts you're going to need or how much storage. So now we get into networking. So what we see here is a high-level overview of the networking model of the SDDC and the customer prem. So what we have here is the customer prem is up top, separated by the internet, and then on the bottom we have the Amazon environment. Now within the Amazon environment we have the SDDC itself, and then the customer VPC. So we'll start with the SDDC. So the SDDC, number one, the first thing to understand is that from a networking aspect, it's broken into two pieces. So we've got the management network and the compute network. Now, each of these networks is bordered by an NSX edge gateway. So we got the MGW and CGW respectively. And so these devices here, these are acting as, number one, north-south routers for their respective environments, but they're also acting as firewalls. And so the firewall policy, by the way, is default deny. So even though these things are connected to the public internet, they have public IPs on them, there's a default deny policy on there so that nobody can actually connect, and it's actually locked down. Now, the networks behind these are NSX logical networks. So these are overlay networks. And so that means we're abstracted away from the underlying Amazon infrastructure. And so Amazon has no direct visibility into these networks. And so that means we're not subject to the same restrictions as you are on a VPC. So for example, VPCs do not allow broadcast and multicast, whereas NSX overlay networks do. And so we can get around some of those restrictions by using the overlay networks. Now, as far as the two networks themselves, the MGW is, like I mentioned, the management network. And so what that means is vCenter, NSX, ESX host, all of that stuff lives within this environment. And so the MGW itself, because of, this is a managed service, we don't provide full access to manage the MGW. Instead, you get restricted access to manage certain aspects, such as, some light ability to manage the firewall, set up DNS, etc. But mostly it's locked down. Now the CGW, on the other hand, that's where your workloads live, and so you have more ability to manage that. So there's no real restrictions on the firewall policies you can create. There is the ability to create multiple logical switches, things like that. So this is where the workloads will live. Now, what we're seeing here is an illustration of what the cross-linking to a VPC actually looks like. So I mentioned all the hosts get ENIs which are then put on a subnet within the customer VPC. So I'm only illustrating one here, but in reality, there's multiple ENIs. And so what we're doing on the back end is we're actually plumbing in one of the ENIs, which happens to be the host where the active CGW is. We're plumbing that through so that it has effectively a direct presence on this subnet. And so as you create and delete logical switches over here, we're basically plumbing in the routes on your VPC so that these networks know how to reach the logical networks. Now that's one of the roles that we've created as part of the account link, and it allows us to do that. Now the other thing to keep in mind here is that even though we have this cross connect here, connectivity isn't by default not allowed, right? Because you've got the default deny firewall policy. And so you'll have the connection there, but nothing can actually communicate back and forth. And so you would actually have to go in and adjust your security policy on the CGW to specifically permit traffic. Now, what we see in here is the IPsec VPN. So the IPsec VPN is a means for which you can connect your on-prem environment directly to these two environments. Now, I have two tunnels here because these, remember, are two separate environments, so they each require their own tunnel. And so once you have an IPsec tunnel in place, you now have direct access to the private IPs within these respective environments. And so that's why people use IPsec. Now, as a stopgap, let's say the IPsec, there's some turnaround time internally, it takes days or weeks to set that up, but you want to use the SDDC now. You can get around that, with a stopgap mechanism by providing direct access through the internet to hosts within these environments. And so, as an example, vCenter server in the MGW is set up with a public IP. Now, the firewall policy doesn't permit any connectivity to it, but it does have a public IP. And so what you can do is if you want direct access to vCenter immediately, you can set up a firewall rule which gives you direct access. You can restrict it down to the source addresses of your environment to kind of lock it down. You can do a similar thing on the CGW by setting up a jump host. So basically you'll take a workload, deploy it as a jump host, give it a public IP, set up a NAT policy for it, and then permit it through the firewall, and then you've kind of got indirect access to workloads within the CGW. And again, that's a good stopgap until IPsec is up and ready. Now, we see here that we've got a lot of connectivity between the different environments. We've got IPsec tunnels connecting the customer prem to the SDDC. We've got the SDDC cross-link to the Amazon environment. And so you see pretty quickly that IP address management starts becoming pretty important. So specifically, you want to make sure that IP addresses you're using up on your on-prem environment aren't conflicting with anything in the SDDC, and none of this is conflicting with anything that's in the Amazon environment. If you end up with conflicting ranges, then what happens is you'll go to set up IPsec and realize that you can't hit anything down here, or when you do this linkage here to the customer VPC, you'll realize that you've accidentally created a black hole, because you've got overlapping ranges. And so IP address management is important. Now, on the CGW, you have full freedom to create networks, and so if you mess up on the IP allocation here, not really a big deal. You can always just delete the logic switch, create new ones. On the MGW, that's not the same story. So the MGW, one of the steps for creating an SDDC is to provide a management network. Now, once you provide that management network, we're actually taking it, carving it up internally, and allocating these IPs to the infrastructure of the SDDC. And so, if you deploy the SDDC and then realize 3 weeks later after you've done all this work on it that, oops, it overlaps with something on my on-prem and now I can't actually reach it by IPsec, there's nothing you can do about that. Those IP addresses are fixed. We've already allocated them. The only thing you can do is tear down the SDDC and start over. And so we like to see that avoided whenever possible. So again, IP address management and planning is very important. So let's get into a bit about workload onboarding and DR. So at a high level, we've got two strategies which I'll talk about. So we've got the greenfield mentality, which is based on pushing ISO or OVA images up to the SDDC and then using those to create fresh new workloads. All right, the other mechanism is the brownfield aspect, and so that tends to be the more popular one, and that revolves around the notion of I've got this existing workload base that I want to move from either my on-prem or another hosting provider into the SDDC. And so when we talk about that, we'll talk about the two rough means of accomplishing that. So the first mechanism we'll talk about is the layer 3 cutover. So for the purposes of this discussion, our use case is data center evacuation. So we're going to start migrating subnets, entire subnets at a time, into the SDDC. And so in this case, we're going to migrate one of these subnets here down into the SDDC. We're going to move the entire subnet. And so what that looks like is if we are migrating the 10.1.1.0 subnet, first step is to create a copy of that in the SDDC. Okay, once we've got that, we can start using one of our migration tools to replicate workloads into the SDDC. Now, once these, once the replication is complete, we're now going to schedule a maintenance window. And during this maintenance window, we're going to do the actual cutover of that subnet. So that means we're going to disable it on the on-prem side, so everything is shut down, including the network itself. And then we're going to plumb in the network on the SDDC side. So now this network is fully routable within the SDDC. Now, because it's routable within the SDDC doesn't mean it's actually reachable from anywhere. So in order to make this reachable, the next step is we have to set up routing on our on-prem routers so that we know to reach this network through the IPsec tunnel. And then we also have to remember to set up our security policies to allow the connectivity, because again, default and iFirewall, that applies to the IPsec tunnels as well. So, that's the individual subnet cutover model. Now, a slight tweak on that is the site cutover model, where we're taking and replicating all the subnets down, and then, in one maintenance window, we're just cutting the entire thing over. And so that's a slight tweak on that. Now, DR sort of falls into the same workflow if you think about it. So DR, for the purposes of this discussion, is let's say that VM1 and VM2 are the workloads that we're replicating for the purposes of DR. Now, in a failure event of the primary site, the idea is that you're sort of doing an L3 cutover. So you're shutting down this side, adjusting the routing, the security policy to make the SDDC the active site. And so it sort of follows the same premise, same workflow. So the next thing we'll talk about is layer 2 extension. So layer 2 extension is a little bit more complex, but it's also a bit more flexible. And so the idea here is that we don't have the ability to migrate an entire subnet in one maintenance window. Instead, our requirement is that we have to move individual VMs during their own individual migrations. And so what that's going to mean is we're going to, we want to have the network that we're actually doing the migration on, we want to have it extended into the SDDC so that we can move individual VMs, and then at the conclusion, once the on-prem side is completely evacuated, we can do a cutover. So what that ends up looking like is, again, creating a replica of that network, which is isolated in the SDDC. We're then going to create an L2 extension, and so now the 10.1.2 network is effectively extended out into the SDDC. So now the next step is we're going to start replicating VMs, and we can either do a replication and then shut down / bring up on this side, which is the warm replication or the warm migration model, or we can do a live migration. And so here we're going to see that taking place. So we've replicated VM4, shut it down on the on-prem side, and then we've live migrated VM3. And so we see here now these are in the SDDC. However, they are not plugged into the routing infrastructure of the SDDC. So all of their routing is done on the on-prem default gateway. So anytime VM2 or 3 needs to talk outside of their own subnet, that traffic is going to go back to the on-prem, use the on-site default gateway. So now once we've got the entire subnet evacuated, we can shut it down, and we can do the cutover. And so that's very similar to what we've seen before. So here we're gonna tear down the L2 extension, shut down the on-prem side, plumb in the networking on the SDDC. So now the migrated network is now reachable, now routable within the SDDC. And then again, we're gonna adjust the routes to make it reachable remotely and adjust the security policy. And so that's the L2 extension model. So a few tools to accomplish the workload migration. So HCX, the first one. So this is a specialized tool that is designed specifically for workload migration. So it has some nice things built in, migration planning assistance. It's got WAN optimization. It's got L2 extension, all these things built into it, into that one tool. And it's also included free with VMware Cloud on AWS. So it tends to be the preferred approach for most people. We've got site recovery used for disaster recovery, but also you can use it, as a mechanism for replicating workloads for workload migration. Also, we've got some native tools built directly in. So, within NSX, there's the ability to set up L2 VPNs, which will do the L2 extension piece, and then you've got hybrid linked mode, for doing migrations of workloads. So you can piecemeal it together with the native tools, or you can go with an all-in-one package, which is HCX. So finally, preparing to onboard. Here's a pre-flight checklist. Basically covers most of the things I've already talked about. So again, identifying the people required to activate the service, making sure we have funding, and making sure we have the Amazon account. Know ahead of time what VPC and subnet you're going to use for the cross-linking of your SDDCs. Make sure that you have IP ranges planned for use within the SDDC. Know how you're going to connect to the SDDC. IPsec VPN, is it going to be a stopgap, just through the public internet? Understand what your security policies are going to be for the SDDC, particularly when you're connecting to the Amazon and environment or back to the on-prem. You want to make sure that you understand what your security profile is going to look like. And then finally determine what your plan is for onboarding workloads. All right, so with that, we're going to go jump to the console tour. And give me one moment to get set up. And by the way, if there are any questions, I know it's a lot of material, but feel free to stop me at any time and ask questions. All right. All right, so you should be seeing my browser now. Let me know if you can't see that or if it's too small. Get rid of that. So my view here is going to be slightly different than yours because this is my own internal org. It's already set up. We already have some SDDCs deployed. And so when you first activate, you're not going to see any of these boxes down here. These are the SDDCs themselves. What you will see is this create SDDC dialog and this invite users. So this is where you create users for the console, the org user / org owner. So let's get into, we won't walk through the creation process. We have a video that kind of covers that already. And so what we'll talk about instead is the SDDCs themselves. And so the first thing I want to point out before I get into an SDDC is this bubble right here. This is a chat window, and so when you click on this is going to open up live chat support to my team. And so if you're having any technical issues, you can request help through the live chat. Now, this is an SDDC I just created, named after myself. So I'm going to click down into that. Now, the first thing to point out is with the live chat support. So generally when you open up live chat support, they're going to ask you a couple of questions, and the answers to those questions are on the support tab, specifically the org ID and the SDDC ID. So they'll generally want to know those two things. You can find them here on the support tab. The other thing that's interesting here is the version that we're typically on. So I'm on the M4 release, and then the public IP and the private IP of vCenter. So the private IP is particularly important if you set up IPsec VPN. You want to be able to access it by its private IP. The settings tab is where our credentials for logging into vCenter are going to be located, and I'll get into that here in a minute when I actually connect to vCenter. Now the networking tab, once it pops up, you'll see it's going to provide a diagram that roughly mirrors the one in my presentation. So we've got the management gateway and the compute gateway with this illustrating showing some your VPN connectivity. Of course, I don't have any VPN setups, so I don't have anything, but this is kind of a high-level illustration for all of that. Now down here is where you actually manage this, manage the MGW and CGW. So we'll start with the MGW. So the IPsec VPNs are the first portion to cover. So this dialog here, if you click on Add VPN, it's going to pop up with some settings for this particular VPN. So we're going to give it a name that's meaningful for us. The public IP is the public IP of the VPN peer on your end. Now, sometimes these VPN devices are sitting behind NAT gateways, and if that's the case, it's the VPN device itself is going to have a private IP, and so you need to put that IP here, otherwise the tunnel won't come up. And now the remote networks, basically this field tells us what is reachable through the VPN tunnel from this end. So in other words, if you have DNS servers or vCenter servers or something that you want to integrate with the SDDC, you want to put those remote networks here so that the management components will be able to reach those through the VPN. And so this can be a common delimited list or just a single supernet address if you have it. Now down here are the encryption options. Now again, these are the configurable options. There are some options that are non-configurable and fixed, and they don't show up here. And so in order to find that information, you want to look in the user guide. And then here we have firewall rules. Now, like I said, default deny. And so we can add new rules that are going to be, permits. Now on the MGW, these rules are a bit more restricted, and I'll show you a specific example here in a minute. But down on the CGW, these restrictions are not in place. The last thing here is DNS. So by default, we're using public DNS servers. If you want to use your own DNS servers, you configure them here. Once you get, particularly once you get like IPsec connection set up, you want to use your on-prem DNS servers, you can configure that here, and we'll use that as our DNS server for the SDDC, for the management component of the SDDC, that is. Now the CGW is very similar, except it has additional stuff that you can configure. So here, logical networks, but by default, we create this one here. So you can view logical networks here. You can't manage them here. You do that through vCenter, and I'll show you that here in a bit. But this is at least shows you a list of them. Again, IPsec VPN, very similar to the MGW side. Firewall rules going to be very similar as well, except more flexible in what you can put in as sources and destinations. If you're getting into, if you want to set up the stopgap jump host solution, this is where you would request a public IP. Once you have the IP, this is where you would set up the NAT rules for it. And then DNS is very similar. You can put in whatever DNS server you want to use, and this is going to be pushed through for DHCP on your workloads if you have it enabled. So let's get into connecting to vCenter. So I'll show you how to do that. So I'm going to implement the stopgap solution. So I don't have VPN set up, and so what I want to do is add a firewall rule that's going to permit me access to vCenter. And so I'm going to call it any to VC. allow action, which is fixed, and then I'm going to say from any source. The destination is vCenter, and the port that I want to access, HTTPS. And so this is the restriction that I'm talking about. We restrict the sources and destinations and allowed ports. And so this is, this restriction is not in place on the CGW. So you can put in pretty much any destination, source, and port that you want on the CGW side. All right, so saving this rule, I've now opened up public access to vCenter. And so NSX is a stateful firewall. So what that means is that I can connect to vCenter and the return traffic is going to come back to me. All right, but you also have to remember that NSX filters bidirectionally. And so that means that if vCenter is sitting there and it needs to initiate a new connection outbound, say to one of the DNS servers or something on-prem, that connectivity is not going to be allowed, right? Because you have to permit that through the firewall. And so you would have to add a second rule if you wanted to permit outbound connectivity, and you would say, VC to any in this example, source is the vCenter server, destination is any, right? And so a rule like that would allow vCenter to initiate outbound connectivity. All right, so now that I've got my firewall opened up, we're going to log into vCenter. And so here is where we're going to get our URL for vCenter server. So we'll get the login prompt. Here is the user accounts. And so this is a UI bug currently showing my login to the console. It's not actually the user. So if I copy out that, what you're going to see is I actually have a cloud admin user. And so this is the default account that's created, and we generate a random password. And so now once this comes up, this is going to look pretty much like vCenter that you expect. And so really the only thing I want to point out here is that within this data center that we've created for your SDDC, what we've created, the default cluster here, and then within that cluster, we've got a pair of resource pools. And so we've got this management resource pool, which contains all the infrastructure. And so as part of the restrictions, you don't have access to that resource pool. So what you do have access to is the compute resource pool. And so this is where your workloads will end up living. And so, again, you have full ability to manage your own workloads, and they just happen to live inside that resource pool. So that's the main restriction. Now, logical switches, like I mentioned, that is done, those are managed through this interface here. And so if you click on menu and then global inventory lists, we will see a section called logical networks. And then clicking on that is going to show, the area where we can manage these things. And so by default, we have this one. If I wanted to add another one, give it a name, determine whether it's routed or extended. Now this goes back to the migration discussion we had. Routed networks are plumbed into the routing infrastructure of the SDDC. Extended networks are not, they're isolated. We can give it an IP address range here, specify the gateway IP that we want to use, and then enable DHCP if we want. Now, the thing to keep in mind is that the IP address range that you specify here, this is a fixed value, so you can't change it once you've created the logical network. So if you end up creating a network that you messed up on, and you want to undo it, basically the way to get around that is to migrate all the workloads off of that network onto a new network and then just delete the old one. All right, so that wraps up most of the tour. The last thing I'm going to show is, now that we're done with the console tour, we're going to lock it back down. And so again, by going into here, going back to our firewall rules, I can simply delete that. And now my access to vCenter should be gone. Right. All right. So that concludes the console tour. We will take. I will stop the recording now and take a few questions if you have them.